you might be wondering, how does this happen? Well, we've actually shown that cutting the DNA leads to and the disruption of the epigenome. And as I mentioned, if you can cause what looks like aging, you can take it away, potentially. So how do you find the original information to restore cellular identity? And the trick was actually to follow in the footsteps of this man on the right, which is he is Shinya Yamanaka, who won the Nobel Prize for discovering genes that convert adult cells into stem cells. So you can reverse aging in the dish, but can you reverse it in an animal? And so we tested that in the lab. We packaged 3 of the genes that Yamanaka discovered, stand for OSK, KLF4, and SOX2. These 3 genes, OSK, we package into a virus. There's a virus here. And we can introduce that into an animal and ask, does it protect the organism? Does it make the organism feel young again? And in this experiment I'm going to show you, what we're doing is testing something that normally doesn't happen in an adult animal, but only happens in a very, very young animal, and that's the regrowth of optic nerves. We all know if we have a spinal injury, as we've heard earlier from Greg, and in this experiment what we do is we pinch the back of the eye, and the optic nerve dies back. As you can see in the figure here, that red area is where the living nerves are, heading away from the eye, but then all of the nerves have died back towards the brain. So you can see this dead area on the left. But if we turn on these reprogramming epigenetic factors, these Yamanaka factors, after the break, after the squeezing with tweezers, what we get is something that would only normally happen in embryos, the regrowth of nerves. And these nerves, actually, if you leave them long enough, will grow all the way back to the brain. Now, we can also reprogram old mice. We've taken 1-year-old mice, 2-year-old mice, introduced the virus into those, turned it on, and within 4 weeks, those mice can see just as well as when they were young, compared to young mice. So that's an interesting thing. Retina can actually be restored in terms of its function, not just slow down aging, as when they were young, compared to young mice. So that's an interesting thing. Retina can actually be restored in terms of its function, not just slow down aging. So finally, I just want to show you something else. I mentioned NAD is important. So that's an interesting thing. Retina can actually be restored in terms of its function, not just slow down aging, as when they were young, compared to young mice. So that's an interesting thing. Retina can actually be restored in terms of... Hello, everybody! With its function, not just slow down aging. So finally, I just want to show you something else. I mentioned NAD is important for controlling these genes that regulate the epigenome. And one of these, I don't know if you can trigger that movie to play, but this is a treadmill experiment looking at mice that have been on an NAD booster molecule. And NAD boosters will stabilize the epigenome and make cells younger. And these mice, if you could see them running, the one on the left has been on this molecule just for 4 weeks, and its muscles are acting as though it's young and can run actually up to twice as far as the control. We published this in a journal just last year. So NAD boosters mimic exercise, as we had expected. And there are clinical trials now ongoing with these and more advanced molecules. So the future looks really interesting. We're close to having molecules. Hopefully we'll see safety and efficacy in these clinical trials. But what does the future look like? Let me just paint that for you. So what if we could truly reprogram our bodies? You could imagine, not just Bill Murray, but all of us could one day be genetically reprogrammed, or at least infected with a virus that could turn on these resetting genes. And in mice, we know that restores the epigenetic clock. You can take the animals back seemingly a large percentage of their lifespan. So what if, in the future, if it's safe, we all have this waiting in our bodies, and if we get injured, with a spinal injury, we just get diabetes, we get dementia, we take a course of an antibiotic, which we actually have shown works to induce these genes in the animal, and perhaps that would lead to rejuvenation, and you go back a decade or two, and then you age for 20 years, and then you go back to your doctor and get another course of antibiotics. And I don't know how many times you can repeat that, but we'll see. So just to finish, I want to give us a glimmer of hope here, because we all know what's coming. No one gets out of this life alive, unfortunately. But my